Pascal's triangle and binomial coefficients. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. One of the most interesting number patterns is Pascal's triangle. Pascal's triangle is an infinite triangular array of integers with many interesting connections to integer arithmetic. Now let's see how to build this triangle. Each number in this triangle can be identified using its row and its specific position with the row. The rows are denoted by n. The rows are numbered from top to bottom, beginning with row 0, n equals 0. Begin by placing the number 1 at the top, then continue placing numbers below it in a triangular pattern. We get the row 1 by adding the number above and to the left and the number above and to the right of our current position. Where the number to the right or left is not present, we substitute a 0 in its place, which is why each row begins and ends with 1. 0 plus 1 equals 1 on the left side and 1 plus 0 equals 1 on the right side for every row. This process is repeated to produce each subsequent row. In other words, keep going, always adding pairs of numbers from the previous row. This can be repeated indefinitely. Pay attention. Let's see some notation regarding Pascal's triangle. The topmost row in Pascal's triangle is considered to be the 0th row. The next row down is the first row, then the second row, and so on. The leftmost element in each row is considered to be the 0th element. Then to the right of that element is the first element in that row. Then the second element in that row, and so on. Now, suppose we wanted to find the second element of the 4th row. We represent that element as follows. The top number is the number of the row. And the bottom number is the element in that row. The second element of the 4th row is 6. We represent the 4th element of the 6th row as follows. The 4th element of the 6th row is 15. The second element of the 3rd row is 3. Pay attention. We can think of this notation as specific addresses in Pascal's triangle. The numbers in Pascal's triangle are called binomial coefficients because they are used in the binomial expansion, as we will see on the next video. In general, we can find any element in Pascal's triangle by using this notation, in which n is the number of the row and r is the element in that row. And to calculate the other binomial coefficients, we can use the following formula. This formula involves the product of consecutive positive integers, so we have to introduce factorial notation. Factorials are very simple things. They are just products, indicated by an exclamation mark. For example, this product is written as and is read for factorial. This product is written as and is read 6 factorial. In general, if n is a positive integer, then n factorial means the product of all the whole numbers from 1 to n. Let's see how it works. Find the third element in row 7 of Pascal's triangle. Take the formula. Replace n with 7 and r with 3. Cancel out like factors from the numerator and the denominator. The third element in row 7 of Pascal's triangle is 35. Find the fifth element in row 8 of Pascal's triangle. Take the formula. Replace n with 8 and r with 5. Cancel out like factors from the numerator and the denominator. The fifth element in row 8 of Pascal's triangle is 56. Pascal triangle patterns. Now that we have seen how the Pascal triangle works, let's see Pascal triangle patterns. What patterns can we see on the diagonals? First diagonal. All ones. Second diagonal. Counting numbers. Third diagonal. Triangular numbers. Horizontal sums. Sum the numbers across each row. Run 0, the sum is 1. Row 1, the sum is 2. Row 2, the sum is 4. Row 3, the sum is 8. Row 4, the sum is 16. What patterns can we see? The pattern is powers of 2.